Hello, good morning everyone. Today is April 12th, 2020. It's Sunday. It's a brand new week for learning. Are you excited? I'm excited too. So please click the pause button right now to gather all the materials written over there. We need Coursebook, extra paper for working. We're gonna have word problem for today for solving, and please get also your pen and notes for note taking. It's gonna be a big help for today's lesson. But if you're ready with that, let's take a look with the mind-boggling question. You have your Guinness World of Record for the fastest thing ever created in the whole wide world. If you're ready, let's go. This is question number 1. This person right over here won the Guinness World of Record for the fastest person to type using his nose. Which country is he from? Let's see if you guess it correctly. He's from India. Correct? Good. Next question. This person, on the other hand, won the Guinness World of Record for the fastest person to eat which food? Think. Do you have a clue what is it? It's no other than the burger. Next question. The football player who sets the quickest goal in a football game in an Olympic. What is his name? I bet he's really famous. You have a wild guess. Who is he? Do you get a correct answer? That's awesome. Next question, and this will be the last. This Australian boy holds the record for solving which material? He only solves it for 16.22 seconds, and he is blindfolded. Pretty smart, huh? Who is he? And what is the name of the material? Let's see if you get it correctly. Did you get it correctly? That's awesome. If you get all 4, kindly put your mark in the comment section below or send me a message. If you get 4, you're awesome. You're really a wide reader. So what do you think is our topic for today? We're talking here about something about fastest thing on the Guinness World of Record. So what do you think? Exactly. Our topic for today is still all about speed, and we're going to do some distance and time graph, and we're going to interpret what is on that graph and how does that affects the interpretation of the speed. So if you have your course book with you, kindly open it on pages 130. We are going also to tackle until 133. So what we're going to learn for today are the following: to analyze the word problem and solve for the time and distance of a moving object. And we already tackled this in our previous video, on a previous topic before, and we're going to focus here on the interpretation for graph using a sample journey graph. So are you ready? Let's go. So when do we use graph? So in this topic, we're going to use the distance and time graph, and we're going to find out the pattern on the graph, and it's going to tell us the pattern of the movement of a moving object. So to delve deeper about what is this pattern of movement, let's take a look with this problem to exercise our mind and to take a look with what is speed, what is distance, and what is time, and what are their relationships. So I have this sample problem for you. Let me just read this for you. Here it is. We're gonna catch the robber. So a robber is in a fast car hurrying away from the crime scene. His car can go at 150 kilometers per hour. He will be safe if he can reach the border, which is 40 kilometers away. On the other hand, A police car arrives at the scene of the crime. The police are late. The robber has already traveled 10 kilometers towards the border. The police car should be in pursuit of the robber. So here is the story, and we're gonna solve here. How can the police catch the robber using the formula for finding the speed, finding the time, and finding the distance? And if you cannot recall what are those formulas, kindly hit the pause button and go back to our previous discussions or previous video. And we need here to catch the robber as soon as possible. So kindly take note of the given in this situation. So if you're done taking note of the given, let's take a look with our problem in the first situation. So look at the problem on this first situation. What are we finding here? We have there the distance, and we have here the speed. So how will I know that this is the speed? Because indicated here is the distance over time. So technically this is the speed, and this is the distance. Why? Because I have here the unit for the distance, which is kilometer. So definitely, what am I finding in here? I want to find for the time. So first, let's answer question A. How far is the robber from the border at this time? So what do you think is the answer? Exactly. He is 40 kilometers away from the border, and he is running right now. So the robber wants to escape the police. So how long will it take the robber to reach the border? So we're going to identify here what are the given. So we have here the speed, which is 150 kilometers per hour, and we have there the time. Is the time given? No, it's not. How about the distance? Is it given? Exactly. So given is the distance, which is 40 kilometers. So we're gonna need here to find for the time. What is your clue that enables you to conclude that we are finding here for the time? Exactly, because of the word how long. So the how long here refers to time. How long will it take the robber to reach the border, given that his speed is 150 kilometers per hour and the distance of the border is 40 kilometers. So we're gonna use which formula now? Exactly. So we're gonna use here the formula T is equal to D over S. So we're gonna write here T is equal to, we're gonna replace these variables with the numerical value. So the numerical value for D is, exactly, it's 40 kilometers, and the speed is, very good, it's 150 kilometers. It's very important that we need to cancel the units. So what units can we cancel in here? So the common variable or the common unit which is found on both of the given here is kilometers. So we can cancel here kilometers, cancel here kilometers, and what is left with us here is the hours. So we're just going to simply divide 40 by 150, and we have here the unit hours. So what is the answer? Exactly, the answer here is 0.27 hours. So why do we express the answer in hours? Because the given here is in kilometer per hour, so definitely we're gonna express the answer into hours. So normally in our problem solving, we pair hour with kilometers, so we don't have any problem here converting the time unit into seconds or into minutes, because we are using here kilometers for the unit of the distance. So how long will it take the robber to reach the border? It's gonna take him 0.27 hours to go or to reach the border. So this is the time to beat for the police if he wants to catch the robber. So here's a situation for the robber. The robber is in pursuit for 40 kilometers border at a speed of 150 kilometers per hour. So it's gonna take the robber 0.27 hours to reach the border. Now the police car arrives at the scene of the crime and the police are pretty late. The robber has already traveled 10 kilometers towards the border. The police car is in pursuit of the robber. So how fast must the police car travel if it is to catch the robber before it reaches the border? So how fast do you think? So first, we'll need to identify what are the given here at a situation of the police car so that we can identify how fast should the police car go. So I'm just gonna give you here some clue. What are we finding here for the police car? Hint, the question here asks for how fast. Exactly. We're finding here for the speed that the police car must have. Given that 10 kilometers is the distance now between the police car and where the robber is. So let's take a look with the given here. So given here are the following. So we have the S, D, and we have the T. So S is the speed and we're fighting for the speed of the police car. So notice that the robber tends to have 150 kilometers per hour. So do you think if the police car runs for 150 kilometers per hour, do you think that it can catch the robber? Well, that is a question we need to answer with this equation. So what is the distance that is traveled here? So the distance that is traveled here is already 10 kilometers away from the police car. So what we're going to do here is to deduct 40 kilometers minus 10 kilometers. Why did we deduct it? So 40 kilometers is already the distance of the border, the distance of the border from where the robber runs away from. So the robber at this moment runs 10 kilometers. That means that the robber still have 30 kilometers more to reach for the final destination. So the distance between the robber and the police is just 10 kilometers. So simply, we're gonna deduct 40 kilometers, the total distance of the border, from the border to where the police are and where the crime had happened. However, this car runs now for 10 kilometers away from it. So we're gonna deduct 40 minus 10, and that will give us the value of exactly 30 kilometers. And the time to beat right now to catch the robber here is 0.27 hours. Alright, so we're gonna need to find for the speed. So again, what is the formula for finding speed? Exactly, it's just simply S is equal to D over T. So the value of S here needs to be found. So we need to replace the D and the T here with the numerical value. So the distance here is 30 kilometers and the time here is 0.27 hours. So simply just divide 30 kilometers by 0.27 hours and that will give you the value of, very good, speed is equal to 111.11 kilometers per hour. So specifically, the police needs to have at least a speed of 111.11 kilometers per hour to catch the robber. So do you think the police can do that? I believe so. Did you get the problem correctly? If you have questions about this problem, kindly send me an image or use the comment below to ask me a question. I'm gonna be right back to you as soon as I can. So if you don't have any other question, let's test how much you've learned so far. Okay, so here is question number 1. Time is up. Do you have the answer with you? Let's check if you get it correctly. So we have here a golf ball was tossed to the goal from a distance of 36 meters. The golf ball has an average speed of 120 meters per second. How long does the golf ball travel? So we need to find out what are the givens. So 36 meters here is the distance, and 120 meters per second is definitely the speed. So we need to find here for the time. So what clue is found on the problem that enables you to find out that it's the time that we are asking for? Exactly. It says here how long. So we're gonna find out what is the formula. So the formula for finding time is T is equal to D over F. And simply replace the variables here with the numerical values. So D is what? Very good. It's a 36 meters here, or 36 m, and the speed here is 120 meters per second. And again, all we need to do here is to cancel the units m and m of the two variables that we used in here. So we can now divide 36 by 120. So the correct answer here is, very good, 36 divided by 120 is equal to 0.3 seconds. Did you get it correctly? So we have 1 mark for this, 1 mark for the formula, 1 mark for the solution, and 1 mark for the final answer with the unit. So take note that on our homework this coming Thursday, when I check it, I need you to cancel the units properly for us to extract which unit are we going to use for the time here, just for example. Alright? If you get it correctly, that's a great job. So let's take a look with question number 2. Please use your extra paper for your working. You have 1 minute to answer this. Time starts now. Solve it correctly. Let's check your answer. So a migrating bird here can travel at a speed of 30 meters per second. How far will it travel in 25 minutes at this speed? So we need to find out what are the givens. The given here is 30 meters per second. This is definitely the good job. It's the speed. And we have here the 25 minutes. The 25 minutes here is the time. However, we have a little bit problem in here. The speed is expressed as a second and it's partnered with the meter, so that means that we need to have our problem expressed also here in seconds so that we can cancel the seconds later. So what we need to do here is to, very good, we need to convert the 25 units. So it said that for every unit, for every minute, there is 60 seconds. So all we need to do there is to write 25 minutes multiplied by 60 over 1 minute. So we're gonna do cancellation of the units. Cancel here minutes from 25 minutes and 1 minute. And what's left here is 60 seconds. So 25 times 60, that will give us the value of 1,500 seconds. So our new value here for our time is 1,500 seconds. So can we solve now? Great. So what is being asked here is the distance. Notice on the problem, it says here how far. So the problem here asks for how far. Definitely we're asking for, exactly, we're asking here for the distance. So we need to find out what's the formula to find for the distance. So simply, distance is equal to speed times time. So we're gonna replace these variables here with the value. So speed is equal to 30 meters per second multiplied by our time value now, which is 1,500 seconds. So simply multiply 30 by 1,500 seconds. So we need to cancel the units. We have here seconds, and we have here also seconds. So cancel. What is left there is meters. So 30 meters multiplied by 1,500, that will give us the value of 45,000 meters. So how far will it travel in 25 minutes? The correct answer is 45,000 meters. Did you get it correctly? Did you get all four marking here correctly? That's awesome. Let's proceed to question number 3. Time is up. Can I hear your answer? What is your answer? Okay, let's find out if your answer is correct. So, a car here is detected by a speed camera. The two detectors are separated by 900 meters. The car travels this distance in 3 minutes. How fast do you think is the car? So, what's given here is 900 meters. And 900 meters is the distance, and we have here 3 minutes, and that is the time. So if we have the distance and we have the time, we're finding here for the we're finding here for the speed. However, I want you to take a look with the time in here. It says here 3 minutes. So we usually pair again the meter here with the second. So what are we gonna do with the minutes right over here? Very good. So we need to convert the minutes into seconds. So it said again that 1 minute is equal to 60 seconds. So we're gonna convert 3 minutes multiplied by 60 seconds over 1 minute. So cancel here the minute. So what's left here is the 60 seconds. So our value here for the time now will become exactly 180 seconds. So just simply multiply 3 by 60, that will give us 180 seconds. So our time here is 180 seconds. So the formula for getting the speed is its speed is equal to distance over time. So let's replace now the variables here with the numerical value. So we have here the distance, and the distance is 900 meters, and the time here is again 180 seconds. So can we cancel any units right over here? Perfect. We cannot cancel anything because there are no similar units found here in these two variables. So just simply go ahead with dividing 900 meters by 180 seconds. So the correct answer is 5 meters per second. So hope that you get a 4 mark right over here. Most especially, be careful with the unit. So how much mark did you get? Did you get all 3 questions correctly? So if you get all 3 and you get 4 marks for every question, the total mark for that is 12. So kindly write your mark on the chat box or on the comment section below. It's well done if you get 12 questions perfectly. Okay? So we're talking here about speed, distance, and time. So the question here is, can a constant speed be possible? Because in the chase between the police and the robber, we had there just one speed that we matched there in the problem. So is a constant speed be possible? I want you to take a look with this one. So a guy here is on a cycling, and for every second, check on the distance that he is moving. So his distance moving right over here, over here, over here, over here, over here. Probably because the road that he is cycling at is not a straight road, or it might be a straight road, there are bumps ahead. So we cannot actually establish a constant speed, and it's very ideal to do that. Why? Because probably there are bumps along the way, it slows down you, or it might be slopey, so you went down pretty fast, or it's a hilly, so you went a little bit slower because you are, cycling, putting on a lot of pressure in it, cycling, and a lot of force or energy. So, it takes you a lot of time to do that. So, however, here in this case, there are, it's like a maze. There are a lot of turn left and turn right roads right over here. So you cannot actually have your constant speed in here, or else you're gonna bump or you're gonna have an accident. So you need to slow down a little bit right over here. So take a look with here that the cyclist here tends to have a different speed as it turns on different corners of the road. So technically, we can establish a constant speed. So what we are using instead is the average speed. So what is the average speed? The average speed speaks about the total speed a person has over a period of time or over the distance which he traveled. Again, because no speed can be achieved constantly over a period of time or over a period of or over a distance traveled, because again of different scenarios that we can face on it. So we use instead average speed. So to check on the different graphs on the average speed, let's interpret the following graphs right over here. So look at the graph. So the graph here shows the distance and the time here in the x-axis. So we call this one the y-axis, we call this one the x-axis. On the y-axis, you can find here the distance. On the x-axis, you can find here the time. So what we have here is to identify what is meant here by the line that is found over here. So look at the dots. The dots here speaks about the intercept between the distance and the time traveled by the car. So the distance and the time of the car is shown below. What can you say about its speed? A, does it increase speed steadily? B, it slows down its average speed. C, it speeds up. So to identify that, let's take a look what is the speed for every distance that the car had traveled. So here it traveled for a distance of 10 meters and for over 5 seconds. So the formula is S equal to D over T. So the speed here is just technically 2 meters per second. So simply divide 10 by 5 and that will give you 2 meters per second. So next is it traveled for 20 meters at a distance at the time of 10 seconds. So what is the speed? Exactly, it's still the same thing, 2 meters per second. How about at 30 meters? Look at the time and what is the speed of the car? Exactly, the speed of the car is still the same, 2 meters per second. And at 40 meters, what is the speed of the car? Exactly, it's 2 meters per second. So what we're doing here is to divide the distance here at where it intersects. It will give you the value of 2 meters per second for every turns, for every point that we have in here. So what can you say about its speed? Is it speeding up? Definitely not. Is it slowing down? Definitely not. So the correct answer here is the car is increase its speed steadily. That means as the car moves at a distance, he maintains its speed. That's why you have there the word steadily. Alright? So let's take a look with the next graph right over here. So here, look, we have two graphs here. It's a little bit the same with what we had before. But in this case, we are comparing two graphs. We have the big car and the small car. So we have here the small car and we have here the big car. So we're finding here which of the two cars is the fastest. Is it the big car or the small car? So let's take a look with the final destination that we had. So they traveled both at 9 meters, but this one traveled for 15 minutes, for 15 seconds I mean. So what is the speed of the red car? So simply divide 9 meters by the 15 seconds as equal to D over T, and that will give you the value of 0.6 meters per second. How about the blue car, the big car I mean? So at 9 meters, it reached it at 35 seconds. So S is equal to D over T, 9 divided by 35, and that will give the value of 0.25 meters per second. So what can you say about this graph? So this graph here, if it's too steep, that means it tends to have a really fast speed. However, it becomes like slopey a little bit like this or leaning toward downward. So it is actually a little bit slower compared to this speed. So the correct answer here is the car with the fastest speed is the small car. So between the two, the small car is faster than the big car. Did you get it correctly? That's awesome. Again, let's take a look here with the next and the third graph. So the speed of the runner is shown below. So what can you say about his speed? So shown here is the displacement. Displacement is the other a way of expressing the distance. So it says about the distance is being displaced or being achieved or being covered, and we have here over the time. So is it that the runner is slowing down, the runner is at rest, or the runner is speeding up, or the runner has the same speed until it reaches 40 meters? What do you think? So to find it out, let's take a look first with the speed of the car, or of the person, at 5 meters in 5 seconds. So S equal to D over T. So it has a speed of 1 meter per second. So 5 divided by 5 gives us 1 meters per second. Next is we have 15 meters in 10 seconds. So S equal to D over T. So that will give us a value of 15 meters divided by 10, and that will give us a value of 1.5 meters per second. So try to see what happened here. Is it steady? Is it at rest? Or is it the same? Next is it reaches now the 40 meters here at 15 seconds. So 40 divided by 15, and that will give us a value of 2.67 meters per second. So what is the correct answer here? The correct answer here is the runner is speeding up. So it does not increase the speed steadily. However, it's speeding up. That means it tends to increase its speed at a course of time here at a distance of 40 minutes. Clear? So again, if you have questions about this, click the pause button and send me an email. Put it in the comment section. I'm gonna be with you as soon as possible. So if you think that you know about this lesson and you kind of like understand this all, so let's try to see how much you've learned so far. So let's gonna test your knowledge. You have your sets of questions. Please click the pause button for you to study on graph A, graph B, graph C, D, and E right over here. So answer the question that follows. If you're ready, let's go. This is question number 1. Which of the graphs here is speeding up? Let's see. Your answer is it's letter B. Speeding up, it increases its speed. Question number 2. Which of these 3 is at rest? Let's see if you get a correct answer. It's definitely letter C. Why letter C? Because look here. At a course of time, it does not increase its distance. So no distance has been covered. That means it's not moving. So if it's not moving, definitely the car is at rest. Next question, number 3. Which of the 5 graphs here, the car or the graph shows that something is slowing down? Let's see if you get it correctly. It's letter D. Why letter D? Because look here, the distance is going down as we increase the time. So as the time increases, the distance decreases. So definitely it's slowing down. Next question, number 4. Which of the 5 graphs here shows that something is on a steady speed. Let's see if you get a correct answer. The answer is, of course, it's letter A. You can see this line right over here. So, how much marks did you get? Did you get all 4? If you get all 4, you were awesome, and kindly put your mark in the comment section below. I really want to know it and record it. However, if you get like 1 or 2, or you have a problem about this, kindly send me an image for clarifications or for questions. I'll be happy to respond about that queries so that you can understand the lesson well. Alright? So if you don't have any other questions, so kindly answer the worksheet I posted last Wednesday, and see you on Tuesday. That will be all. Goodbye.